Hey everyone, it's the LectureDude. Today I'm going to go over what's called row operations, or what I like to call it, finding x. Because your normal equation comes in the form ax equals b. If you have a and you have b, like here, then what you're solving for is x. So the way we do this is first we use matrix multiplication to pull out the x and the y. So they're multiplied on the side like here. Then we have our a and our b. Nice simple format. Then we want to write it in augmented matrix form. What that means is that we basically ignore the x and y until the end. Okay? We pretend it's one big matrix. Now, there are three operations we can do to this augmented matrix to find our answer. We can swap our rows, which is the equivalent of writing these in a different order. It doesn't change the answer. We can add the rows together, because this is the same x and y. We can just add equations to find the answer. And we can multiply each row by any number we want. This is the same as multiplying both sides by that number. If it's an equation, you can multiply both sides, and the answer won't change. So, using these three things, these three operations, we're going to solve this system of equations, which is this augmented matrix. So let me just walk you through that right now. So, to solve, what we want to do is we want to make the a part equal the equivalent of 1, because anything multiplied by 1 is itself. So we want to get rid of that. To do that, we want to make this diagonal all 1s. So from top left to bottom right, it should be 1s, and then the rest should be 0s. So we want to clear out each column of 0s. We got a number right here, okay? So we'll make that our 1, which means this is our 0. Similarly, we'll make this our 1 going down the diagonal, which means the rest of the column is 0s. So first we're going to try to get rid of this number. Make that a 0. Well, remember, we can multiply and we can add. And swapping won't do much here, but we can multiply and we can add. If we multiply by a certain amount, add by a certain amount, we can get that 0. So let's multiply it into a number that we can add easily. So we'll multiply this top part by 2. So 2 times row 1, and we'll multiply it, well, that comes out to 10, 18, and 6. Multiply this bottom part by -5. So that comes out to -10. This is why we chose those numbers, because these add to 0. And we have to keep on going with the rest. This is 20, and then times -5 is 70. Now we just add the rows. So we're trying to make this one 0, so we'll add both of them into the second row. So the second row equals row 1 plus row 2. Now, first row doesn't change because we're not doing anything to it. So 10, 18, and 6. Second row, we're adding the first row to it. So 10 minus 10 is 0. 18 plus 20, 38. And 6 plus 70 is 76. Now, these are large, annoying numbers. So let me rewrite this smaller so that we have more space to work with. Alright. These are large, annoying numbers now. We want to get rid of those if we can, because those aren't very easy to work with. And remember, we're just trying to get this 1 anyway. So if we multiply this row by 1 over 38, we can get that common factor out. Same up here, there's a common factor of 2. So let's just simplify. So 1/2 R1 and 1/38 R2. So divide this by 2 and we get 5, 9, 3 again. Divide this by 38 and we get 0, 1, and 2. That's a lot nicer. So now we got this column is 0. Now we want this column 0 except for this number. So let's multiply, how about this row, by -9. So -9 times R2. This row doesn't change. This row, -9, -18. Now we add them together. So we're adding them to the top one this time. So we're adding row 2 to row 1. So we have, this is 0, which is really nice because it doesn't change anything. It just stays as 5. This becomes 0, and this becomes -15. This is still 0, -9, -18. Now that we have our zeros, all we have to do is divide out the numbers until we're left with only ones and zeros. This is called reduced row echelon form, when you have a diagonal of 1s and the rest are zeros. So to get this to be 1 and this to be 1, we just divide by itself. So row 1 divided by 5, and row 2 divided by 9. That comes out to 1, 0, -3, and 0, 1, 2. Now we have our answer. But how is this our answer? Well, remember, we just hid the xy. So this is the same as 1, 0, 0, 1 times xy equals -3, 2. Remember that this is our identity matrix. What that means is that if you have a matrix that's 1s down the diagonal and the rest are zeros, if you multiply something by that matrix, it's the same as multiplying by 1. The matrix doesn't change. So, in effect, this doesn't change anything. And we're left with x equals -3 and y equals 2. This row reduction will work for any system where you're trying to solve for the x vector, if you're given the b vector, and your A matrix. So I hope you enjoyed my lecture. If you have any questions or comments, please leave them in the comments section.